Okay, today we're going to look at quadrilaterals in the coordinate plane. We're going to start by looking at a couple of things that we know just about plotting points. So let's go ahead and plot some points. Negative 2, 2. We're going to plot 0, 2, 0, 0. So the origin and the point negative 2, 0. And then the question is, what shape is that? You probably don't need to connect these dots to get the shape here, but I will just out of great habits. Um, What shape was formed here? That is very clearly a square. Let's make that stand out a little bit. And then what is the length of each side? You can probably just look at that and know that the length of each side here is 2. You could do the distance formula if it weren't a nice neat square, but in this case the square is right on the coordinate plane, so we can just count units. So that is 2. Let's take a look at the next page. Recall that coordinates are of the form x, y, so that's x and then y. Um, so they come alphabetically. Points positioned on the x-axis are in the form x, so whatever number they're at, and then the number 0, um, because they're on the x-axis, so there is no vertical change in those points. And it's the same exact thing for the points that are positioned on the y-axis, except for they are 0 first, so they don't go left or right at all, just up or down whatever the y is. And again here they go left or right how whatever the x is, and then they don't go up or down at all because they're on the axis. Quadrants. We need you to know the quadrants. We need you to remember what's what. So if we could label the quadrants real quick, we want to start in the top right corner. We start where everything is positive. So that's quadrant 1. Uh, and then we go counterclockwise. For those of you working on a digital watch, that's not going to make any sense to you. So you have to actually know how to read a clock. This is, and then go the opposite direction. So this is counterclockwise for the quadrants. So if you could label those. So again, those are our quadrants 1, 2, 3, and 4. What we need to be able to do in this unit is find missing coordinates. So observe the following figure. This is a rectangle or square or something of some kind. I know that because it has the same height. So the slope here is 0 and the slope here is 0, and the slope there is undefined and undefined there. So I need to find the length of AB. The length of AB is really the measure of how far it is from point A, which is the origin, to point B. Well, I don't know what it is in numbers. I don't know if that's 7 or 8 million or point 0.2. There's no way to tell how far it is in numbers, but I can tell that the difference between A, which is 0, 0, and B, which is A0, I'm looking at the length of AB, so it's just the horizontal change, which is A. We go from 0 all the way over here to A. A could be 4, 10, 100, like we said. We don't know what number it is, but the length of AB is A. Now we also want to know what's the distance from B to C. So from B to C, it's similar to finding A, except for here we are at B right here, and we're going to go up. So it's asking how far is this distance here. The x's aren't, the x coordinate is about horizontal change. The y coordinate is about vertical change. So to go from on the x-axis up to C, we traveled A again. So now not only do I know that this is a rectangle of some kind, more specifically because the length and width are the same, I can say that this shape is a square. The key here is to not get caught up into figuring out, well, how actually far, how far is that point actually, or, what is it really, or anything like that. The question is given variables, can you figure out the length of sides of different quadrilaterals? And here we can. That's a pretty easy one, so we start there. Let's take a look at another one. So here we're going to find the missing coordinates, and we're given this. This is not obviously a square rectangle. This is a rhombus, and so we have to be able to figure some things out. We're trying to figure out this coordinate here. We're trying to figure out how far would I have to go on the x-axis to get over to this point, and then how far would I have to go on the y-axis to get up to this point. This isn't easy. It takes some figuring out, but we can do it. We just have to do it one small piece at a time. To do that, we need to know how far is it from here to here. Well, that's A. That part makes sense to us. But this other distance that we're given, it's A, but then we went this much further. Okay? That distance on a parallelogram, or a rhombus in this case, is the same as this distance. Okay? So what we're saying here is that we're going to go from 0 out A and then out this much more. Well, I can figure out that distance because from here to here was B. We went over this far and then up to get to this point, and I know the x coordinate here is B. So we can say that on this shape, to get all the way out to here, we went over A plus B. So that's the x coordinate. The x coordinate actually is an expression. It is A plus B. The y coordinate is just how far from here up. Well, from there up right here is the same as it was right here. Well, the y coordinate for this point is C, so the y coordinate for this point is also C. The point here that we were missing was A plus B, comma C. It seems complicated. I promise it's not. What you'll have to really make sure you do is you might have to find a missing part like this that you can add on over here. Sometimes we'll have to subtract. It depends on which way the shape is facing. So take a second, try this one, and we'll see what you get.